Hello everyone and welcome back to the channel. Today we are going to talk about how to refine vascular model geometries for use in ANSYS. So first let me show you an amazing website where you can find a ton of diseased arterial geometries for both humans and different species. So just go to your browser and search for vascular model repository. So here is vascular model repository, and just go to the site and just click enter in the open the database. Just enter into the database. So here you can see that there are so many datas of vascular model. So you can find your required one. There are various vascular model of disease like aneurysm, like lymphocyte and stenosis. So here in the filters option, you can find your required one. So I'm just showing you. You can define the range of age. Then you can define for male or female. So I am here defining female. You can define a species. So I'm just defining human. And there are anatomy. So here I am finding, as I am finding cerebral aneurysm. So I'm just clicking on cerebral. Then the disease which I require is aneurysm. So I'm just clicking on aneurysm. Okay. So so here I don't need to select aneurysm. Just by selecting cerebral and aorta, I can find different aneurysms here. So I can see there the aneurysm disease, and in this geometry, this geometry, this geometry. Now if I just choose one, here all the simulations files are given. So now even though this site already provides simulation results using a different software, you can easily extract the raw geometry to run your own simulations, apply your own boundary conditions, and analyze the data inside ANSYS. So for using it in ANSYS, you have to extract it. But importantly here, the geometry files here given are not ANSYS supported format. So you will have to first export that in ParaView software to get the ANSYS supported format from the ParaView, and then you can export it into ANSYS for your simulation. So here I'm just downloading the model. I'll just download it. So it is being downloaded. So my download is complete. uh, I'm just going to the location of my download. So here it is a file I have downloaded. So here in the models, you can see the model is in two format. One is MDL and one is BTP format. So which are not supported format in ANSYS. So you will have to open it in ParaView software, and you will have to um, convert the format into ANSYS supported format. So I'm just opening ParaView. Okay, ParaView has been opened. So I will I will open the geometry. So this is my file, this is the model, and this is actually BTP format. So the model will be in BTP formats. So here after in properties, I will click apply. So here you can see the model. So the model has been exported uh, successfully. So here now what I will do is I will just save this same model. I will go to save as. So I will save the data, and here you can see there is various formats, and here only the ANSYS supported format is STL format. So I will just select a folder. I will just save it in the model. So I'll just give a name, model 1. So I'm just saving it here. Okay. So you can see that model has been saved as STL format, and now I can export it in ANSYS for my further application. So here I have opened ANSYS. I'll just take Fluid for Fluent, and here one more thing to say is you can just download ParaView software from the website and just easily can install it. So there will be no issues. So here in the geometry section, I will browse for my model which I have saved as STL format. I will go to the folder and go to models, and here you can see that the STL format is here, and you can simply just import it, and you can just go to SpaceClaim. You can see that the model has been successfully imported here. In my previous video, I have shown you how to extract a 3D blood domain and artery wall because these are only faces. This is a surface geometry and not a 3D body. Now I will take 3 planes on the inlet and outlet sections of the artery. So this plane will be required for further smoothing of the inlet and outlet sections. Now I am just hiding these planes, and if I just show you, just double click on that, and if not all the surfaces are selected, then you can just move it above, then just right click and delete facets, and you can see that this is totally a surface geometry of surface meshing. So I am just deleting this, double clicking and deleting all this inlet and outlet facets. Now if I just show you the diameter of the artery, just click measure and click 2 points, and it will give you approximate diameter, which is approximately 8.4 millimeter. But here one important thing is that the geometrical dimension of the cerebral artery given here is not the actual dimension. So you will have to scale it down to the actual dimension, and you can take the dimension from published literature paper. So I have taken a dimension of the artery diameter from a published paper, which is 3.4 millimeter, and the artery and the thickness of the artery wall is 0.3 millimeter. So you will have to scale it down, and for this just take a origin, and the origin is for the scaling reference point, and then just click pull and scale body, then select the origin and then select facets, And since uh, the actual diameter I'm taking is 3.4 millimeter, so the scaling factor will be 3.4 divided by 8.3, and which is like 0.4. So just pull it down with a scaling factor of 0.4. So it has been scaled down, and again just you can see the dimension. So here you can see that the dia is 3.3 millimeter approximately. So it is near to the published data. And now just use thicken tool under the faces tab and just give offset thickness of 0.3 millimeter. So just double click on facets. So you can see that thickness has been constructed over the surface geometry, but here you can see that the mesh here is very much distorted and not very smooth. For this I will use shrink wrap tool, and for this shrink wrap there is a thumb rule to use 1/3 of the artery thickness in sizing. So I'm just using 0.1 millimeter, and I will then click faces and click here. So it will just take some time. So here you can see that a very fine and smooth mesh has been constructed over the artery wall body. So now for my final geometry I will use tools tab and auto skin tool, select shrink wrap and just click for my final 3D geometry of artery wall. It will also take some time. So as you can see that the final geometry has been constructed, and now the planes I have taken will require here with this plane. Okay, I'm just uh, hiding the origins, and then with these planes I will just cut the inlet and outlet sections to have a smooth surface. I'll just use move tool, select the plane and just moving it to a dimension, and then I'll select split body, select the body and selecting the plane as cutter. Then I will just remove this portion, and you can see a smooth surface has been created. And I will just do the same for the other two outer sections. So just selecting the body and the plane as cutter, just removing the part. So here the body has been split into two body. So here I will just use combine tool to combine this two body into single one, and just click patch body and just control click patch body one and just click here. So this will just take some time, and yes, it has merged the two bodies into a single body. So I will also just cut these sections with these planes. So this is also done here, and I have just three smooth faces on the in the outlet and on the outlets. Sorry, in the inlet and the outlets. So now my final work to be done is creating a 3D blood domain inside the wall. So for this I will just use volume extract tool under the prepare tab, and I will select faces, and I will just select this faces, and after selecting these faces I will select once seed face, and I will just select the inner face, seat face, and I will just right click here, and you can see a smooth 3D domain, a 3D volume for blood domain has been constructed here. So you can just see this is my 3D domain for blood flow, and this is my artery wall. So this is the final geometry. Thank you everyone for being with me, and if any query you can just comment below or ask me, or any question via message. So thank you everyone again. Thank you very much.